The second question is we are looking for the derivative of exponential minus 4x. We do the same thing. The first function here is our exponential. Exponential is the first function. The second function is our minus 4x. So that is why we are going to find the derivative using the chain rule, because this is a function of a function. A function embedded into another function. So minus 4x was embedded into an outermost function of exponential. Is that okay? So we now say let u equals the inner, u is always equal to the innermost function, which is minus 4x. Good. So u is equal to minus 4x, and if u is equal to minus 4x, we can say let's assume we have y equals to exponential minus 4x. That's exactly what we have there. And our u is already equals to minus 4, so we can say y is equals to exponential u. That is what happened here. Is that okay? If we differentiate u in respect to x, we get minus 4. Of course, we know that. Now, if you differentiate exponential anything, it will give you exponential that thing. If we differentiate exponential Bolaji, it gives you exponential Bolaji. If you differentiate exponential your name, it gives you exponential that thing. If you differentiate exponential mathematics, it gives you exactly that thing. So exponential u will give us a derivative of exponential u. Using our formula, we just put our value. So the y du here is exponential u. That's why I have exponential u here. Then the u dx is minus 4. So I have minus 4 times exponential u, which will give me minus 4 this will give me minus 4 exponential u, right? And recall our u is equal to minus 4x, right? So instead of u, I'll write minus 4x. And that is how we got the solution to this question. Let us quickly look at this, our third question. Our third question says find the derivative of this. Now, before we can find the derivative of this so that it will be easier for us, let us simplify this function. Now we can rewrite this to give something like this: 6 over, now square root, remember our popular saying using the laws of indices, the square root there can be equal to this one, the square root can be equal to 1 over 2 here. Is that okay? Now we can break this to give something like this: 6 over 1 times 1 over 2x plus 1, everything raised to the power of 1 over 2. Is that okay? Good. If you multiply this, you see it still gives this. Is that okay? 6 divided by 1 will give us 6, right? Then remember our laws, from our laws of indices, if we have 1 over anything, it gives us a raised to the power of minus 1. Is that not so? So this 1 over becomes 2x plus 1, then minus 1 over 2. The 1 over here gives us our minus, and that is how we got this. Is that okay? Good. Let's clean up our slide quickly so that we can continue. Now, the innermost function here is 2x plus 1. Good. Then the outermost function is 6 times something raised to the power of minus 1 over 2. So this is a function of a function. We use our chain rule, but before that, let's assume our u is equals to the innermost function, which is 2x plus 1, right? Good. Now, if u is equals to 2x plus 1 and our y is equals to, we can say y will be equals to 6, right? Then u is 2x plus 1, so we write u, then everything raised to the power of minus 1 over 2. Is that okay? Good. If we differentiate u in respect to x, we get 2, of course. If we differentiate y in respect to u means there is no, is u we are considering as our variable here. So minus 1 over 2 multiplies this our 6 here, and we have u minus 1 over 2, then we subtract 1 from it, right? Good. This will give us 6 divided by 2 will give us 3, so we have minus 3 u raised to the power of minus 3 over 2, and that's how we got this our differential here. Then the next thing we do, very simple, we just put in the value of the u dx and the y du into our chain rule formula. Now doing that, we get 2 times minus 3 u raised to the power of minus 3 over 2. 2 times minus 3 will give us minus 6. Good. And our u, recall our u is equals to 2x plus 1. So instead of u here, what do I write? I write 2x plus 1. So my answer is minus 6, 2x plus 1, everything raised to the power of minus 3 over 2. Good. And we can write this as having minus 6 over 1 times we can have 1 over 1 over, then we can have 2x plus 1, everything raised to the power of 3 over 2. Is that okay? 3 over 2, and if we multiply that together, we have minus 6 over 2x plus 1, everything raised to the power of 3 over 2. This is a simplified version of that question. In our next section, we are going to look at a very simple shortcut to solving this function in less than 30 seconds. Tune in for that.